But today we'll speak about Modbus. And as a first slide, I have some questions here. We have a computer here, or a BMS system, that should get information from a TA-Slider. And the questions I have today is, how do they talk to each other? And then how is the signal transported from the computer to the correct TA-Slider? And how does the computer know what to ask for the slider and what it receives? And we'll also see today the difference between Modbus RTU and Modbus TCP. So there's a small difference between them, but basically they're the same protocol. So the agenda for the presentation is to first cover master-slave, and this is to answer the question, how do they talk to each other? The next thing is cables and network. So this is how is the signal transported from the computer to the TA-Slider. Then the third point is registers. So how do the computer know what to ask for and what it receives? And then we'll see some examples on Modbus configurations, two common things that you could use Modbus for. And the last thing is to advertise a practical exercise that's already on LittleJohn and IMI Learn. So let's kick it off with the master-slave principle, which is how do they talk to each other? And to explain this, I'm going to use this simplified graphic to illustrate how they speak with each other. And on it, I have a master, and the master is connected to two slaves. And the master is what it sounds like, the one who is deciding everything in this network. So we're going to look at how a typical communication in Modbus looks like with this master-slave principle. And the master here, what the master do is that it asks a question to the network. And the master say that he wants to speak to someone, and then what information it wants to receive. So it could say, I want to speak with number 2, and I want information A, B, and C from this slave. So a signal is sent through the network. A signal is traveling along some cable, and it comes to the first one, and it says, I want to speak with number 2. I want information A, B, and C from number 2. This is not number 2, so it will just say I'm number 1, and the signal will carry on. I want to speak with number 2, and I want information A, B, and C. And slave number 2 sees the master wants to speak with me, so the slave will respond, I'm number 2, and my information to ABC is 1, 2, and 3. So the information I have is 1, 2, and 3. And then the signal is traveling from the slave back to the master, and it's I'm number 2, and my information is 1, 2, and 3. So this way the master have found what it's asking for from the right slave. So this is a typical master and slave communication. Usually the master is not a person, but a computer, some BMS system in a control system. And then you have wires connected to your slaves. How the wires and networks look, we will see in future slides. But the slave can be any Modbus device, really. So it doesn't have to be a slider. It can be a TA-Smart or a brain cube as well. The master-slave principle is still the same for this one. So on the question, how do they talk to each other? It's through this master and slave principle. So the master is deciding everything. They decide who should speak, what they should say, and the slave is only answering on requests. So it cannot just speak by itself and say whatever it wants. It only answers the request from the master. And it's the same principle for both Modbus RTU and Modbus TCP. The next chapter is cables and network. So how is the signal transported from this master to the right slave? And here we will see why it's called Modbus RTU and why it's called Modbus TCP. So we still have this simplified graphic about the master and slave network, but our question now is what type of cable is used to connect the master with the slaves? And how are they connected? And how is the right slave contacted? So the master asked for slave number 2, but we'll see how they actually name the slaves in these networks. And the first topic of this one is the cables. So we have one cable for Modbus TCP and one cable for Modbus RTU. And for TCP, we use these Ethernet cables, very common. You see them in your computers. So a very standardized cable that manages the communication. And TCP is available on the big sliders. So Slider Plus with Modbus 750 and Slider Plus with Modbus 1250. And then we have Modbus RTU, which use another type of cable called RS485 or twisted pair cable. And these are available for small Modbus slider as well. So 160, 500, and then also 750 or 1250 if you want RTU instead of TCP on these ones. And the cable is a twisted pair, and the pair is the A and the B cable. So you see here there are two sort of main cables on this one, and an earth shield cable as well. And these twisted pairs have voltage signals that communicate the bits. So the signal here is transported through the A and the B cable. So there's different cables depending on if you have Modbus TCP or Modbus RTU. And the first network and cable we look into deeper is the RTU network. So here we have the RS485 cable between the devices, the twisted pair with the A and the B. So the cable connecting the master with the first slave is this cable. And then the second slave in this one would be connected in a daisy chain. And what that means is that the cable goes into the first slave. So in this case, we have the example here of a slider. We have the main cable from the master going into the slider. And then we have one cable from the slider to the next slider. So this would be the next slave. And since they're connected like this, it's called a daisy chain. So between each slider, there is a twisted pair managing this Modbus communication. And then there's one twisted pair to the master as well. And to name the slaves, we use something called a slave ID or a RS485 address. So we can name them here between 1 and 247. And the slaves need to have a unique name because when the master is calling for someone to respond, you can't have two slaves with the same name. So they have to have a unique name in this network. So here in this example, the first slider is slave ID 1. The second one is slave ID 2. And now we're going to look into the cables that you can have with your sliders for RTU networks. And for slider 160 and 500, there are pre-made cables for this to manage both the power supply and the communication. So in your daisy chain, you have these white cables that you might recognize. And you have three different types of cables, A, B, and C cable. And the first cable is called A cable. And this is the one that connects the first slider in your daisy chain network with the master. So if this would be to the master, this would be the A cable going into your first slider. And they look like this in reality. There's one plug, and then there are 5 open cables here. And when we look into the data sheet, we can see what each cable means. So we have the shielding line for our twisted pair. We have 24 volts. And we have 0, so the ground. And then we have our A and our B cable here to manage the communication in this RTU network. So you remember we have a twisted pair cable in RTU networks. And these are the A and the B signal, or the data plus or data minus, they're sometimes called. So the red one and the black one on this cable are the communication cables. And then the brown and white is for the power. And then you have the shielding wire as well for the green one. And it's very simple on the slider to just plug it in the right way. And the right socket would be to the right pin here. And then you need to connect your open wires here into your control unit. The second cable is the B cable, and this is the cable that goes between your different sliders. So when you have a daisy chain, you have a cable between each slider, and the cable looks like this. It's the same end on each one, and you can just connect your sliders very simply with this one. You use your right and your left socket to connect your sliders in this daisy chain. So this is the B cable. You can see in the data sheet, it looks like this. And then you have your C cable. And the C cable is used for three things mainly. It's a power booster. It's a 0 to 10 volt input, if you would like that. And it's also where you connect your PT1000 sensors if you want to read temperature of your slider. And the cable looks like this. It's the same connection, and it goes in the middle of the slider. So here you see a slider with both a B cable here, a B cable here, and then a C cable in the middle. And on the data sheet, you can see how it looks with the different colors of the open wires and how they should be connected. So the brown one here and the white one is again for power, 0 to 10. And this is to, if you have a lot of sliders in a row, you can't supply it with only one cable to get the power. So therefore you need to provide extra power into your daisy chain. And this is what you use your C cable for. Or if you would like to control a slider with 0 to 10 instead of Modbus and only receive the data back with Modbus, so a hybrid mode, you can use the C cable to connect your 0 and 10 cables here, the white and the green one, to your slider. And then you can control it with 0 to 10 volt. And the last thing is that you can connect a PT1000 sensor as well to your cable and your slider. And by that, you can read your temperature in your slider and send that back with Modbus as well. So these are the three cables you use for slider 160 and 500. A cable to connect the master with the first slider. B is to connect the sliders between each other. And then C to give extra power if you have a long daisy chain, to control 0 to 10 or to connect a PT1000 sensor. So you might ask yourself, how many sliders can I have in a daisy chain? And this is limited by three things. I make some advertisement for Little John at the same time. If you want to read this in detail, you can go and search for how many TA-Sliders can I have in a backnet or Modbus daisy chain. And it's written here in detail. But what it's limited by is the power supply. So how many sliders you can have before you need to boost your power. The available addresses, so these unique names that you need to have on each slider in this network, is limiting this. We had 1 to 247. And then it's also depending on the available data traffic on the cable. So on this A and B cable, we can only transport so much data, and therefore we can't have an infinity long daisy chain. So this is also limiting how many we can connect in a row. So if you want to know this and how it's limited, you can go on Little John after the webinar and see it for all the limitations here. For 750 and 1250, it's a bit different. Here we don't have the pre-made cables, the A, B, and C cable, but here it's up to the customer to arrange the cables. So just like for a brain cube that you want to use with Modbus RTU, there the customer have to get the twisted pair and power as well. So it's the same with the slider 750 and 1250. So there you have this RS485 board with your A, B, and ground or shield connection. So you have your twisted pair cable with your A and B signal that you connect into your board here on the slider 750 and 1250. And then the power cable and the 0 to 10 volt signal go on the main circuit of the slider, and the bus cable go to this optional this board here. And you can also do a daisy chain with these ones and connect your A and B into your A and B ports here. The next thing we'll look into is how we configure our RT network. So once we have connected our cables, so we have power and data source to all our sliders, we'll see how we need to configure them. And here I have a TA-Slider 500 Modbus as an example. And you can see here, it's if you click on the bus, you will go into the bus settings for this slider. If I would click here, I would come to this page here. The first thing it says is bus type. So here you can confirm it's an RTU, Modbus RTU. The second thing you read here is baud rate. And baud rate is essentially how fast your electrical signal is transmitted on your A and B cable. When you're sending your signals on your A and B cable, the slider and the master will do this with a certain speed. So they will send power on or power off with a certain speed. And this is the baud rate. It's very important that all the masters and slave have the same baud rate, because if they would not, then you would have maybe a master that would try to speak in a certain speed, and your slaves would try to listen for the signals with another speed. So then they would miscommunicate with each other. So it's important that they speak and listen for the signals with the same speed. So this is the baud rate, so it should be the same for all. The second thing is the parity. So this is just to ensure that the data package that is sent is complete. So when you're sending these data packages with Modbus, you have something called a parity bit at the end of this package, just to make sure that all the data was sent correctly. So it's just a way for the network to control that the signals are sent and received properly. The second thing is the slave ID. So this is the unique name you have of your slider in your daisy chain. So this must be unique and between 1 and 247. So you can name it to whatever you like, as long as it's unique on this one. And then you have something called a terminal resistor that you can activate or deactivate. And this should always be active for the last slider in your daisy chain. So when the signal is traveling along your daisy chain, at the end, it must have a terminal resistor. And this is just to make sure that the signal is good, so you don't have any signal bouncing back, you could say, on the daisy chain. So just remember that the last TA-Slider needs to have terminal resistor active. The automatic device name you can leave, and we speak about hybrid mode and bus binary input a bit later. So Modbus RTU, if we should summarize this, you have your cable here, twisted pair, and for 160 and 500, you have your A, B, and C cable. And if you have 750 or 1250, the customer need to arrange this with their own twisted pair cable. And your network is built with this daisy chain going from the master through each slave. And here it's important to make sure you have the same baud rate for everyone and the same parity bit for all. So just make sure they speak with the same speed and that the confirmation of the signal is done properly. And then you have the name, which is done with this slave ID. So that was the RTU, Modbus RTU. Now we're going to look at the Modbus TCP network instead. And here we had a different cable. It was this Ethernet cable. And this one you should connect through switches or routers. So your master is going to be on your network, and you're going to use a switch or a router, and you're going to connect your slaves into this one as well. So just like you have at your office or at home, if you have multiple computers, they're all connected to the router. So it's the same principle. It's a TCP IP network. And just like computers or phones, they will have IP addresses here. So instead of having a slave ID, they will have an IP address to be their name. So that is how you make sure that they have a unique name when the master is speaking with them. So it's not a daisy chain anymore, but a TCP IP network. And the names here are IP addresses instead of slave IDs. I'm going to show how to configure a TCP. So here we have a Slider 750 Modbus TCP. So you go into Modbus TCP again. And here we have a confirmation again that it's Modbus TCP. And then you have something called DHCP. And this is a dynamic IP. So if this one is activated, then your slider will ask for a dynamic IP from the router back. So the router will name your slider. So you cannot name it itself. So it's not very good for static equipment to have these dynamic IP addresses that can change, because if they change, then the master will try to speak with the slider when it have changed the name. So usually it should be a static one. So if you just deactivate DHCP, you will be able to configure your IP address yourself. So here you see it's deactivated, and here you can name your slider to whatever IP it should have. So just click there and you can change that. And then you have your TCP configurations as well. So the subnet mask, gateway, and port. Usually this is done by the IT technician. So they set up the network, TCP, and they have their own network rules. So they can just configure however they have configured their network to be with these ones. Usually they're quite standard. But for security reasons, for example, they can change this. Port is usually 502 for Modbus. So just like gateway and subnet mask, you don't have to worry a lot about this, but this is done for the network configuration by the customer. And the same here, automatic device name, it's just the name it will have on the network when you see it as an open device there. So usually just leave that device as it is, automatic. If you want to name it to whatever you like, you can do that, but it's not very common or really recommended. So for Modbus TCP, the cable here is the Ethernet cable instead of the twisted pair. The network here is a bit different. You don't have your DC chain, but the network is done via routers and switches, just like for your computer network, or if you connect your phone to the Wi-Fi. You have your subnet mask, gateway, and port that needs to be right, and then you name it with an IP address. So it also has to do with the network a bit, but the name here will be the IP address. So cables and networks is different for Modbus, TCP, and RTU. You have different network rules, how you connect the wires and how what configurations you need to make. RTU, you have that baud rate and parity bit. TCP, you have your gateways and ports. The cable is different, Ethernet and twisted pair. And then we're going to name our slaves different as well. So the unique name will either be a slave ID or an IP address. So we had our question here at the beginning of the webinar. How is the signal transported from the computer to the correct TA-Slider? So either it's through a TCP or Ethernet cable or a twisted pair cable. And every slave will have a unique name. So the master will know this unique name. And if it's a TCP, it will be an IP address. And if it's RTU, it will be the slave ID instead. If it's TCP, the local network will manage the communication. And if it's RS485 or RTU, the cables need to be connected correctly, this twisted pair A and B. And the baud rate and the parity bit needs to be set up correctly for all devices. So that is the cabling and network for your different Modbus RTU and TCP, depending on what slider you have. The third question we had was, how does the computer know what to ask for and what it receives? And this is called registers, or Modbus registers. And I have two questions on this chapter here. So how is the data categorized and how does the computer know what to ask for? And on the right here, I have Modbus holding register for TA-Slider 160. And I will explain how this works and how you read it. And below here, I have an image of a file cabinet. So I will try to make an analogy between the file cabinet and a holding register, just to try to explain how it looks. So if we go into this holding register, we have some different headings here. We have register, address, size, access, value range, and description. Description is the description of the data, what it means. So it could be input position. It could be to activate or deactivate the relay. Request a force calibration. So just explaining what the register is doing or what you're going to read or do in that register. Then you have the value range or the format of the data. It will tell you what range your data will be and how it will look. So here you will have 0 to 10,000. Your data will be somewhere in between there. So that will be your input position, like 0 to 10 volt, but 0 to 10,000 instead. Or relay 0 and 1 to either activate or deactivate it. Request a force calibration you do by having a 1 in this one and a 0, you don't do anything. So the value range is describing what the data will be and what format it will have. Then we have access, and here you can read R and W on many of them, and a lot of them also have only R. So R stands for read and W stands for write. So read means you can only read what the data is. So current position, for example, here on address 12 is an R, so you can only read the current position. While the input position is something you can make an input on as well, so that's more a write. And a read as well. So you can read what you have as input, and you can also make a writing there. So write what you want to have as an input. Size of the data is just telling you how many registers it is. So usually it's 1, can be 2 as well. If it's a big data, then you need to have 2. And then address is really how you know where this data is located. So I had a question before on the previous slide, how is the data categorized and how does the computer know what to ask for? And this is the addresses and the value range, what it's really describing. So I had my file cabinet here. Now I'm gonna pretend that I am a slave. So I work as a slave and I sit at my office and I have a file cabinet. And my files are stored in different folders, and each folder have an address. So I have folder 0, folder 1, folder 3, folder 4, and so on. And when the master asks me, I want to know the value you have in your folder 0, I go into my folder 0 and I tell the master maybe 5,000. So what I read in my folder will be what I answer the master. And then the master knows what value range it will be and the input position. So when he's asking for folder 0 or address 0, the master knows this is the input position and it knows the value range it will be in between. So therefore it can interpret it. So these addresses could be like folders in a filing cabinet, and in there you have the data that you can have described here, and it will be within the value range you have here. So I'll make an example here. The address number 12, the master asks the slider for the data in address number 12, which is the current position. So the value it receives back will be 2,150. So it's somewhere between 0 and 10,000. So this scale will be from 0% to 100%, you could say. So you can say that this is 21.5% open. So since you know it's the actual position and you receive the data 2,150 back, you can interpret it as 21.5%. So let's look at our simplified graphic again, how it could look. The master will ask number 2, give me the data you have in register 0 to 15. And then slave number 2 will look in the file cabinet and say, I'm number 2, and the data is 6,600, 00156. So this will be the signal back to the master. And then the master can interpret the data because in address 0, it knows it's the input position. It gets 6,600 back, and then it knows it's 66%. In address 1, it receives 0 back, and then it knows it's the relay, so it's deactive. So thanks to this Modbus register and this explanations here, the master know what address it should ask for, and once it receives the data back, it knows what that data means. So this is the whole protocol, you could say, how they communicate. So it's the master-slave principle. You have your cable and your addresses, and then you have your registers to know what data to ask for and know what data it receives back. So we had the question here, how is the data categorized? So it's categorized in different registers, and every register have an address, and every register have a value range. So on the question, how does the computer know what to ask for? It knows this because we programmed it to ask for certain registers, and then we know the value we get back will be something that's described within a certain range, and we know what address that data will be in. So thanks to these holding registers or Modbus registers, the computer can know what to ask for and what it receives back. And this register is the same for Modbus RTU and Modbus TCP. So I'll go back to the first or the second slide I had on this presentation, which was a computer to get information from a TA-Slider. So how does they talk to each other? And there we had that master-slave principle, that the master is dictating and the slave is just responding. How is the signal transported from this computer to the correct TA-Slider? It's through our cable and network settings and our unique naming of the sliders or the slaves. And this is different for Modbus RTU and Modbus TCP. And how does the computer know what to ask for and what it receives? And this is the registers. So thanks to the registers, the computer can know what addresses to ask for, and the values it receives back, it can know what that is. So what is the difference between Modbus RTU and Modbus TCP? It's just the cables, the networks, and the names. The master slave is the same, and the register is the same. So now I'll show two examples of configurations that you can make with a TA-Slider. And the first one will be something called a hybrid mode. So this is, I would say, quite common. It's when you want to control your slider with 0 to 10, and you still want to collect data. So you want the data back from your network, and this you collect with Modbus. So this is called hybrid mode. So you work both with analog signal and you work with a digital Modbus protocol. And right now I'm going to show how the settings are done with this TA-Slider 500 Modbus. You see here, input signal for this one is bus communication. So right now this will be the register input position, where the master could write between 0 and 10,000. A value it would like the slider to be. And we want to change that because we want to have the control with 0 to 10 volts instead. So if I click on bus and go in there, I have my bus settings here again, the RTU, the baud rate, parity, slave ID, and so on. And then I have hybrid mode here below. If I activate this one, I will activate another input into my slider. So if I go back to the main menu now, you can see it's different here. The input signal is proportional 0 to 10 instead. So now it will have this C cable connected to it to have a 0 to 10 volt input. And the slider will not respond to a bus input on the position now, but on this 0 to 10 volt input instead. So that's the first example I had, the hybrid mode. And then you can configure your input signal to 2 to 10 if you like to have it reverse, a different characteristic if you don't want it linear, and so on. So just like you can do with any slider. The second example I'm going to show is the bus binary input. So this is just like a normal binary input, except that it's done with your Modbus register instead. So you don't need to connect a real physical binary input. You just need to have it connected to your Modbus network. And you find that in address number 4. And you see it's both a read and a write. So you can set it to 0 or 1 to change this binary input. And this is also done in bus configurations. So if you click here on bus, you come in here again, it's the same menu. And below hybrid mode, you have bus binary input. If you click on that one, you'll come into this menu here. You can see it's set to none at the moment. You could do a flushing with it. So if you would select flushing here, you could activate the flushing of the valve by using this bus binary input to write a 1 to that. Or you can have a bus changeover. So if I would like to select a bus changeover because I would like to have maybe another stroke limitation of my valve, I can do that. So I click bus changeover. Now you see it's expanded here, mode, it's cooling, and then you have your limited stroke here. If you go into your limited stroke, you have your actuator stroke, your maximum, and then you activate your stroke limitation, and then you could click here on stroke limitation, and then you will have stroke limitation for your cooling and stroke limitation for your heating. So depending on if you would write in your Modbus 0 or 1 to this address or this register, you would change between these two stroke limitations. And if you would like to do it with flow instead, let's say it's mounted on one of our PIBCVs, you go to your valve selection, you select your PIBCV, and then the stroke limitation would look like this instead. You would have your flow or stroke. So if you have flow, you could limit it on the flow, or you could do it with stroke. So that's just like a normal binary input if you would like. But you do it with your Modbus register instead. The last thing I'm going to show is to just advertise an exercise that's live on IMI-Learn at the moment. You can find it on Little John as well. So this is a practical exercise that you can make to understand the Modbus registers better yourself and to configure a slider to get more experience in that. So if you go on Little John and search for TA-Slider 160 Modbus Daisy Chain Explained, you will find it. Or if you go on IMI-Learn and search for it, you will find it there as well. And the exercise is to make the settings, make sure the stroke limitation setting is at 10, mount your slider, connect all the cables and wires. Here you see you will do it with an A and a B cable, and connect your power source and connect your data source A, B, and your ground to your computer. So your computer will be the master. Then you will configure all your sliders using your TA dongle to make sure that their settings are right. And then you will do readings in your computer with RMMS software. So you will pretend to be a master, and you will be able to read the different registers and write the different registers. So you will do your settings with the bitrate parity here for your Modbus master as well. And then here in the right picture, it's a screenshot from when you will be reading from your different registers. So register 0 to 9, 10 to 19, 20 to 29, and so on. And then we'll compare what we read with our high-tune application and what we read in the holding registers, so to see how they actually work.